Hello, hi everyone. Welcome to the next one shot video of this series. In this video, we are going to discuss some previous year questions of thermodynamics and thermochemistry. So, by the end of this video, you will have a solid grasp of syllabus, weightage, and how to apply the thermodynamic concepts to solve the problems, which enhances both your theoretical and problem solving skills. So, let's get started. So, first, how to use this video? So you have to revise your short notes, then you have to write down the important information, and then you can start doing the practice, right? And then you can start solving the questions. But first discuss the weightage. If I talk about the weightage, then the weightage is around 7%. In every set, we have two questions from thermodynamics. Syllabus, I'm going to discuss with the mind map, and then we will solve the previous year questions. So let's discuss the mind map. Let's discuss the mind map. So in the thermodynamics, we have some basic terms. So basic terms related to system, surrounding, boundary, properties, right? Then we have first law of thermodynamics, zeroth law of thermodynamics, second law of thermodynamics, and the third law of thermodynamics. In the first law of thermodynamics, we relate internal energy change with the heat energy and the work done. Okay. In the second law of thermodynamics, we have certain formulas with respect to the entropy and the Gibbs free energy. Okay. We have different kind of processes like isothermal, isobaric, isochoric, adiabatic, polytropic process, cyclic process. So we have number of formulas with respect to that. So before solving the questions, please learn all the formulas so that you can relate the questions in a better way. Then we have thermochemistry. So in the thermochemistry, we have the different types of enthalpies for different kinds of reaction, right? So in thermochemistry, we have to discuss about heat of reaction, how to calculate heat of reaction with respect to heat of formation, heat of combustion, and bond energy. So we have different kinds of enthalpies. So I have divided the entire thermodynamics and thermochemistry into the 8 problem types. So in 8 problem types, I am going to discuss almost each type of question for the concept clarity. And before solving the question, I will discuss the concept in a very short way so that you can relate it in a better way. Okay, so let's get started. Let's discuss type 1 problem, which is completely dependent on the basics of thermodynamics. If I talk about the basics of thermodynamics, so that is related to thermodynamic terms. So we have system, surrounding, and boundary. So what is system? System is that part of the universe which is under the observation. Now the rest part of the universe is going to be surrounding, and system and surrounding, they are separated by a boundary, right? Now this boundary, it can be real or imaginary, right? It can be real or imaginary. It can be rigid or flexible, and it can be adiabatic or diathermic. So what is adiabatic? Boundary where heat exchange in between system and surrounding is equal to 0. It means there is no heat exchange in between system and surrounding, then that boundary is going to be the adiabatic boundary. But if the heat can be exchanged in between system and surrounding, then that boundary is going to be the diathermic boundary. Okay, then we have some functions like state functions and path functions. So what are state functions? Which depends on initial and final position, right? And which depends on the path followed by the system in order to go from state A to state B. So that is going to be path function. So we have two path functions generally, like work done and heat. They are going to be the path function, while other terms, other thermodynamic terms or thermodynamic parameters like internal energy, enthalpy, entropy, Gibbs free energy, temperature, pressure, volume, they are all going to be the state functions. Now we have some thermodynamic properties, that are intensive properties and extensive properties. So what are intensive properties? Cannot be additive, cannot be additive or subtractive, or subtractive. While extensive properties, they can be additive or subtractive, additive or subtractive. So how to identify what are intensive properties? So intensive properties where number of moles are fixed, like molar volume, Gibbs free energy per mole, pressure, temperature, all the concentration term where amount of solute is fixed, like molarity, normality, boiling point, freezing point. If we have some kind of constant like refractive index, है ना, pH, vapor pressure, these are all intensive properties. While the properties which are dependent on number of moles or the amount of substance, right? That is going to be extensive properties. That volume. It means suppose we have a system, okay, and if I'm going to divide this system into two equal halves, then what happens? Suppose initial volume, total volume, it is 2 liter, and if I divide the system into two equal halves now, or if I divide the container into two equal halves, so now the volume is going to be 1 liter and 1 liter. So that is going to be extensive property, right? But the pressure which is exerted onto this container, that is going to be same. If initially the pressure was 1 atm, so after the division of this system, pressure is going to be 1 atm. So pressure is going to be intensive property while volume is going to be extensive property, right? Number of moles additive hai, subtractive hai. So number of moles, entropy, enthalpy, these are all extensive function, right? Now we have some thermodynamic process like isothermal, where temperature changes 0, so dt is 0, or we can say delta t is equal to 0. We have isobaric process where pressure is 0, dp is equal to 0, or we can say delta p is equal to 0. Isochoric process, it means dv is equal to 0 or delta v is equal to 0. Adiabatic process where q is equal to 0, it means there is no heat exchange in between system and surrounding. And then we have the cyclic process. So what are cyclic process? Where initial and final position, it is same, right? That is going to be the cyclic process. Now we have thermodynamic processes. So thermodynamic processes, they are classified into reversible process and irreversible process. So what are reversible process? Which takes infinite time to complete, right? Which takes infinite time to complete. Wherever irreversible process, right, they take finite time to complete. Finite time to complete. All natural processes, they are irreversible process. All natural process, they are irreversible process, right? In reversible process, equilibrium is maintained at every step, while irreversible process, if we talk about the irreversible process, so equilibrium is maintained only at initial and final position, right? Initial and final position, or initial and final step. That's it, right? So we have the question based on the basic. So the question is the total number of intensive properties from the following is. So we have volume. So see, if we talk about the volume, so see, if we have a system, if I'm going to divide the system into two equal halves, so suppose initial volume, it was 1 liter. So after the division, so V1 is equal to half liter and V2 is equal to half liter. So basically volume is extensive. Next, we have molar heat capacity. So what is heat capacity? Heat required to increase the temperature by 1 degree Celsius, right? So if we have molar heat capacity, it means heat required to increase the temperature of 1 mole of the substance by 1 degree. So this is going to be intensive. Next, molarity. It is intensive. If we have suppose 1 molar solution, right? So 20 ml of that solution, molarity is going to be 1 molar. Even the 50 ml of that solution, molarity is going to be 1 molar. Then we have E naught cell. So E naught cell is also intensive. It is not going to change. E naught cell of, if I say zinc 2 plus 2 zinc, E naught for this one, that is going to be same. That is going to be same. That will not change. Then we have Gibbs free energy. So Gibbs free energy is extensive, but if we have Gibbs free energy per mole, that is going to be intensive. Then molar mass intensive, and number of moles extensive. Okay, so the total number of intensive properties from the following, that is equal to 4. Intensive properties, total intensive properties, they are equal to 4. Right? So answer is 4. Is it clear? So let's move to the next problem type. Type 2 problem, which is based on float and heat capacity. So what is float? Float is first law of thermodynamics. First law of thermodynamics. Okay. And what is heat capacity? Heat capacity is the amount of heat required to raise the temperature by 1 degree Celsius, or we can say 1 Kelvin. So that is equal to the heat capacity. But before starting with the question, let's discuss some basic formulas and basic uh, terms which are required in order to solve the question. So first of all, important part is the sign convention, right? Sign convention, they are very important. So what happens if the system absorbs heat, right? Then we have to take Q is equal to positive. It means magnitude we have to take positive. If the heat is released from the system, then we have to take magnitude of heat energy as negative. Okay, if work is done on the system, which is called compression work, and in the compression work, what happens? Final volume is actually less than the initial volume. Okay, and if work is done on the system, then the work is going to be the positive. We have to take the magnitude of work as the positive, right? Now, if work is done by the system, which is the expansion work, where final volume is greater than the initial volume, so for that we have to take work is equal to negative, right? Then we have float. Float is the mathematical form of the float. First law of thermodynamics states that energy of the isolated system is going to be constant, and mathematical form is internal energy change is equal to the Q plus W, right? Where Q is the heat energy, right? Q is the heat energy, delta E is the internal energy change, and W is the work done. So in thermodynamics, work done is actually PV work done. We have to take the mechanical work done. So we can write delta E is equal to Q plus minus PV, right? Q plus minus PV. Why we are taking minus PV? That is, if I say minus P delta V. So here minus P V final minus V initial, right? If final volume is greater than initial volume, then it is going to be the expansion work and the work is going to be negative as per the sign convention. And if final volume is less than the initial volume, then this whole term is going to be negative, and negative it becomes positive. Then that is going to be the compression work, right? And now if I want to find out the work, so if pressure is in atm and volume is in liter, so the work unit is going to be atm liter. But in question it is asking calculate the work in terms of joule, right? Calculate the internal energy with respect to joule, kilojoule, calorie and all. So that is the important part. What is the important part? You have to learn these relations. One calorie is equal to 4.184 joule, right? Which we can take as 4.2 joule also. And 1 liter ATM is equal to 101.3 joule, right? 24.206 calorie and 101.3 into 10 to the power 7 hour. So basically you have to learn this. You have to memorize this. Is it clear? Okay. Now we have the heat capacity. So heat capacity, we have molar heat capacity, we have specific heat capacity. So what is specific heat capacity? Heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius. So that is going to be specific heat capacity. What is molar heat capacity? Heat required to raise the temperature of 1 mole of the substance by 1 degree Celsius. Okay, so we have certain formulas for that. If we write heat capacity is equal to Q by delta T, right? Now heat to the system can be provided by two ways. Matlab it can be provided to the system by two ways, either at constant volume or at constant pressure, right? So if we have constant volume, so we can write CV is equal to QV and n delta T, why n? Matlab if we have 1 mole or n mole, so we can write in that way. So we have QV is equal to n CV delta T, which is equal to delta U. So one formula is this, right? One formula is this. Now next formula is Cp is equal to Qp upon n delta T, which we can write as Qp is equal to n Cp delta T, and which is equal to delta H. So one formula is this. So we are going to use this formula in order to solve the question. So let's do the question based on these terms or these concepts. So first question, which one of the following equation does not correctly represents the first law of thermodynamics? Right? And ideal gas is there. Ideal gas means PV is equal to nRT, and first law of thermodynamics is delta E is equal to Q plus W. Assume non-expansion work is zero. Matlab the work which is involved, which is there, but that is not responsible for the change in volume. So for that work, we have to take it as zero. So now see, if the cyclic process है, so internal energy, it's a state function. It means it depends on initial and final position. So if we have the cyclic process, initial and final position is same, so we can say internal energy is equal to 0. So if internal energy is equal to 0, so what we can say, Q is equal to minus W, right? Q is equal to minus W. So this is going to be true. Now second is we have adiabatic process. So for adiabatic process, Q is equal to 0. So if Q is equal to 0, so we can say delta E is equal to W. Delta is equal to W, and W ko we can write delta is equal to minus P delta V, right? Because W is equal to minus P delta V. So here it is written delta U is equal to minus W. No, this is incorrect. This is incorrect. ठीक है? Now for isocoric process यानी delta V is 0, volume change is 0. So it means work done is 0, and we can say delta E is equal to Q. So this is true. This is true. For isothermal process, delta T is equal to 0. So internal energy is equal to 0, which is NCV delta T. So if delta T is equal to 0, so internal energy is equal to 0. So it means we can say that Q is equal to minus W. So that is also true. So the answer is option number 2, which is the adiabatic process. Okay, which is the adiabatic process. Now let's do the next question. 5 moles of an ideal gas at 100 Kelvin are allowed to undergo reversible compression. So N is equal to 5 mole. Temperature is equal to 100 Kelvin. They are allowed to undergo reversible compression. It means reversible process. And compression means final volume is less than initial volume, right? Till its temperature becomes 200 Kelvin. So if I say initial temperature T1 is 100 Kelvin, so T2 is equal to 200 Kelvin. Okay, and we have to find what? Calculate delta U, yani internal energy. Delta U is the change in internal energy, and we have to calculate delta PV. Okay, CV is also given 28 joule per Kelvin per mole. Okay, so fine. So which formula we are going to use? We have to find out internal energy change, which is delta U is equal to N CV delta T. So N is 5 mole. What is the value of CV? 28, and delta T is 200 minus 100. So it is equal to 5 into 28 into 100. Okay, 5 into 28 into 100. So on solving, you get 14,000. That is joule per mole, and this is going to be 14 kilojoule, right? 14 kilojoule. Clear? 14 kilojoule. So now we have to find out what? Delta PV. So see, how to find out delta PV? PV pressure is not given, right? Volume is not given. But we know that here it is written ki ideal gas hai. We have ideal gas, right? We have ideal gas. So if we have ideal gas, so it means equation is PV is equal to nRT and delta PV is equal to delta nRT, or we can say nR delta T. So n ka value is 5, R ka value we have to take it as 8, and delta T is 200 minus 100. Okay, so 200 minus 100, so it is 5 into 8 into 100, so which is equal to 4000 joule, or we can say 4 kilojoule. Okay, so if we see the option, so option 3 is the correct answer. Delta U is equal to 14 kilojoule and delta PV is equal to 4 kilojoule. Okay, now let's do the next question. Among the following, the set of parameters that represent path function. So path function, we know that. What are path function? Heat, heat, heat and work, right? So they are path functions. They are path functions. So see, this is path function, yes. This is path function, yes. Let's see Q plus W. So Q plus W क्या है? Delta U, Q plus W. But internal energy change, that is the state function. That's why we can find out delta U, na? So state function means that U2 minus U1 we can find out, right? Then we have H minus TH. So H minus TH is basically delta G. So delta G is equal to delta H minus T delta S. Okay, so delta G also a state function. It depends on initial and final position. That's why we can calculate difference G2 minus G1. So what is the answer? Q and W, or we can say 2 and 3, or B and C. So B and C, that is going to be the correct answer. Okay. Now let's do next question. During compression of a spring. Compression of a spring means obviously volume is V final is less than initial. Work done is 10 kilojoule. Work done, spring, the work is 10 kilojoule, compression है. So it means compression work, it is going to be positive, so we write plus 10 kilojoule. And 2 kilojoule escaped to the surrounding as heat. Yani escape, heat is released from the system. Yani we have to take negative, so minus 2 kilojoule. So the change in internal energy. So change in internal energy is equal to, we have to use float, first law of thermodynamics, Q plus W. So Q is minus 2, work is 10, so that is equal to 8 kilojoule. Right, so internal energy change is 8 kilojoule. So answer is 8 plus 8, not minus 8. Okay, that's why sign conventions are important, right? That's why sign conventions are important. So option 3 is the correct answer. Okay. Now let's do next question. What happens when methane undergoes combustion in system A and B respectively? So combustion of methane means CH4 on reaction with O2. It gives CO2 plus water, right? It gives CO2 plus water. So combustion hai, so this is the exothermic process. Exothermic process means heat is released along with the formation of product. So heat is released along with the formation of product. So if we have adiabatic system means we cannot exchange the heat in between system and surrounding. So if we cannot exchange the heat in between system and surrounding, that what happens? Due to the heat released during this process, it increases the temperature of the system. So we can say temperature rises. And if we have the diathermic process means where heat can be exchanged with the system and surrounding, right? So it means exothermic process hai, so heat is released from the system. So if heat is released from the system, then the temperature remains same. So that will not change the temperature. So as per the option, Answer is going to be A. System A, temperature rises. System B, temperature remains same. Why? Because heat is released from the system. Right? If we have the diathermic container or system and surrounding, they are separated by a wall, diathermic wall. Okay. Now, let's do the next question. Write down every information, right? Just try to write down every information. So, that's the important thing. Next, an athlete is given 100 gram of glucose. It means glucose mass, it is 100 gram. What is glucose? C6H12O6 for energy. And this is equivalent to 1800 kilojoule of energy. This is equivalent to 1800 kilojoule of energy, right? So, if we have 100 gram, so equivalent to 1800 kilojoule of energy, yani Q is equal to 1800 kilojoule. Now, the 50% of this energy gained is utilized by the athlete for sport activities at the event. Now, 50% of this energy, 50% of this energy is going to be 50 by 100 into 1800, which is equal to 900. So, it means 900 kilojoule of heat energy is utilized by the athlete for sports activity at the event, right? In order to do some kind of activity. In order to avoid the storage of food, or storage of food is storage of energy, the weight of extra water he would need to prepare is, right? So extra water, in order to avoid storage of energy, matlab that energy he cannot store. So he need to remove the energy in the form of sweat. So how to solve this? How to solve this? So see, 900 kilojoule of energy is required to do activities. So rest 900 kilojoule of energy he need to perspire, right? 900 kilojoule of energy, right, is need to, or we can say he needs to perspire 900 kilojoule of energy. So how to solve this question? See, enthalpy of evaporation of water is 45 kilojoule per mole. It means 1 mole water for evaporation of 1 mole of water, 45 kilojoule energy is required in order to evaporate 1 mole of water. So it means 1 kilojoule of energy is equivalent to 1 by 45 mole water, and 900 kilojoule of energy, it is equal to 900 upon 45 mole of water. ठीक है? So if we solve this, so we get 45, 900 upon 45. So we get 5 or 20 mole. So 20 mole water, right? 900 upon 45, that is going to be the 20 mole of water, right? So now 20 mole of water is equal to 20 into 18, because 1 mole water mass is 18 gram. So 20 mole water is 20 into 18, which is equal to 360 gram water, right? So question is, in order to avoid storage of energy, the weight of extra water he would need to perspire. So that is equal to 360 gram. 360 gram. I hope this question is clear. Okay. Now let's do the next question. When 2 liter of ideal gas expands isothermally into vacuum, right? 2 liter of ideal gas expands isothermally. So volume is 2 liter. Isothermal means delta T is equal to 0 into a vacuum. Vacuum means when we do not have any external pressure, that is equal to 0, right? To a total volume of 6 liter. So if V1 is 2 liter, so V2 is equal to 6 liter. So the change in internal energies. So see, change in internal energy, how to find out? So delta U is equal to Q plus W, or we can say Q minus PV. Or we have the formula delta U is equal to NCV delta T. So isothermal process, delta T is equal to 0 for isothermal process. So it means internal energy change is also equal to 0, right? So answer is 0. Answer is 0. Okay. So now let's do next question. The internal energy change in joule when 90 gram of water undergoes complete evaporation. It means H2O liquid, right? It is converted to H2O gas. At 100 degrees Celsius, temperature 100 plus 273, that is equal to 373 Kelvin. Okay, so how to solve this? How to solve this? 90 gram of water है, so 90 gram water means number of moles 90 upon 18, which is equal to 5 mole, and delta H for this is given, that is 41 kilojoule per mole. So see, we have one more formula which can relate delta H and delta U, which is equal to delta H is equal to delta U plus delta NGRT. Okay, delta NGRT. So delta H is, so delta U is what? Delta H minus delta NGRT. Okay. So delta H is 41 kilojoule. So it means 41 into 10 to the power 3 joules. Delta Ng, yani number of moles. Delta Ng is what? Number of moles of product in gaseous state minus number of moles of reactant in gaseous state. So here 1 minus 0. So that is equal to 1. ठीक है? That is equal to 1. Clear? Now, ठीक है? Let's do this. So, delta NGRT 1, R का value you have to take 8.314 and temperature is 373. So, we have to solve this. So, on solving, you get 37898 joule. But that is for per mole, na? Per mole. But we have 5 mole of water. Na? So total internal energy change is 37898 into 5, which is equal to 18949.39 joule. 18949.39 joule. Okay. So answer is going to be this. You have to select the option, right? The options are not there, but the answer is this, right? 18949.39. Now let's do next question. The heat of combustion of ethanol into carbon dioxide in water is heat of combustion of ethanol. So ethanol is CH3 CH2OH plus O2. So combustion, the product of combustion is CO2 and water. CO2 and water. So we get on balancing, we get 2 carbon, then hydrogen, 3, 4, 5, 6 on the left hand side. So here we write 3. Okay. And then we have oxygen 4, 5, 6, 7. Right? 4, 5, 6, 7. So we get 3 O2 and this. Okay, fine. So the heat of combustion, delta H of combustion is minus 327 kilocalorie at constant pressure. So the heat evolved in calorie at constant volume. So heat evolved at constant volume, it means we have to find delta U, right? Internal energy change. And 27 degrees Celsius temperature is 27 plus 273, which is equal to 300 Kelvin. And R ka value you have to take as 2 calorie per mole per Kelvin. Okay, fine. So we have this formula na, delta U, or we can say delta H is equal to delta U plus delta NGRT. So internal energy change is delta H minus delta NGRT. Delta H is minus 327. Delta Ng, right? So delta Ng is how much? So this is gas, this is liquid, CO2 is gas and water is liquid. So delta Ng is 2 minus 3, which is equal to minus 1. So minus 1 R का वैल्यू 2 and temperature is 300. So minus 327 plus 600, right? 327. अच्छा, here kilo calorie है, here kilo calorie है. So we have to take minus 327 into 10 to the power 3. So minus 327000 plus 600, right? Plus 600. So we get minus 326400, right? Minus 326400 calorie, or we can say minus 32.64 kilo calorie. Okay, kilo calorie. Next question. An ideal gas undergoes isothermal compression. Isothermal compression means delta T is equal to 0. Compression, ideal gas है, we have ideal gas, it means PV is equal to nRT. Compression है, so V1 is 5 meter cube and V2 is equal to 1 meter cube. It means V final is less than V initial, right? Against a constant external pressure which is equal to 4 Newton per meter square. Heat released in this process is used to increase the temperature of 1 mole of aluminium. Heat released in this process is used to increase the temperature of 1 mole of aluminium. If molar heat capacity of aluminium is this, so molar heat capacity of aluminium is 24 joule per mole per Kelvin. Okay, fine. ठीक है, fine. So how to solve? The temperature of aluminium increases by, temperature of aluminium increases by. So see, we have delta U is equal to Q plus W. Internal energy change is equal to Q plus W. Now delta U is equal to 0. Why? Because isothermal process. So we have Q plus W. So Q is equal to minus W. And W is minus P delta V. Okay. So which is equal to plus P delta V. Plus P delta V. So from here, Q is equal to P external pressure, that is 4, and delta V is equal to 5 minus 1, or V final is 1. So we can say 1 minus 4. Clear? So 1 minus 4. So 1 minus 4 means minus 16. Okay. Okay. 16. So it says heat released in this process is used to increase the temperature of 1 mole of aluminium. Now, if molar heat capacity of aluminium is this, molar heat capacity is this, it means Q is equal to NCV delta T. Why I am using this? Q is equal to NCV delta T. Because molar heat capacity of aluminium is given 24 joule per mole per Kelvin, right? So, we can say Q is equal to minus 16 and 1 mole of aluminium, CV it is given 24 and delta T, right? Delta T. So, it means delta T is equal to minus 16 upon 24, right? 16 upon 24, which is equal to minus 2 by 3. 2 by 3. So, question says the temperature of aluminium increases by. So, the temperature of aluminium increases by 2 by 3 Kelvin, right? So, the temperature of aluminium increases by 2 by 3 Kelvin. It's simple now. We have to find out the delta T only. Delta T means T2 minus T1. So, it is equal to 2 by 3 Kelvin. Okay. So, answer is this C. Now, let's do the next question. For a diatomic ideal gas in a closed container. Diatomic ideal gas. Okay. Which of the following plots does not correctly describe the relationship between various thermodynamic quantities? So we have Cp versus P. So this is heat capacity at constant pressure. Heat capacity at constant pressure. So see how to solve this. We know that. What is Cp? Cp is equal to Qp upon N delta T, or we can say Qp is equal to Ncp delta T, right? So Cp at constant pressure, because Cp is what? Heat capacity at constant pressure. So if we plot Cp versus P, so it should be the parallel line to x-axis. Parallel line to x-axis. So this is the incorrect. This is the incorrect. The answer should be 1 only, but let's check the other options. The second option is internal energy change versus time, right? Internal energy versus time. So we know that na U क्या होता है? Internal energy delta U, it is equal to NCV delta T, right? Or we can say internal energy is directly proportional to temperature. Internal, if you increase the temperature, then internal energy of the system increases. So we can say yes, it can increase, right? ऐसा हो सकता है, it is possible. So on increasing temperature, internal energy increases. So it is possible. Now we have CV and delta T. देखो CV versus V, it is clear, it is okay, because CV is what? Heat capacity at constant volume. So if we plot the curve in between CV versus V, right? CV versus V, so we get the parallel line to x-axis. So this is true. This is true. Now if we talk about CV, so that can also be true. So CV is equal to what? QV upon T, na? QV upon T, right? So this can also be true. This can also be true. That's it. So answer is going to be 1. Now let's do next question. For 1 mole of an ideal gas, which of these statements must be true? 1 mole ideal gas. U and H each depends only on temperature. Yes. Delta U is equal to NCV delta T and delta H is equal to NCP delta T. Both depends on temperature. True. Compressibility factor Z is not equal to 1. So see, Z is what? Compressibility factor PV upon RT. So for ideal gas, PV is equal to nRT na, for 1 mole, right? So in order to make PV is equal to RT, compressibility factor value is equal to 1, right? So ideal gas के लिए compressibility factor is equal to 1. So this is false. Now we know that Cp minus Cv is equal to R. We have this relationship in thermodynamics. So this is true. And du is equal to Cv dt. Yes. Du is equal to NCV dt. Yes, it is true. Right. So we have to find out the statements which are true. So what are true statements? A, C and D. So option 4 is the correct answer. Now let's do the next question. At constant volume is constant. It means delta V is equal to 0. 4 mole of an ideal gas when heated from 300 Kelvin, T1 is 300 and T2 is 500 Kelvin. Its internal energy change is 5000 joule. So the molar heat capacity at constant volume is. So how to solve this? Delta U is equal to N CV delta T bete. N is 4. CV का value is CV. We have to find out. Okay, CV we have to find out. Delta T 500 minus 300 and internal energy change, it is equal to 5000. So solve. So CV is equal to 5000 divided by 4 into 200. So on solving, we get 50 upon 8, right? 50 upon 8, or we can say that it is equal to 25 upon 4. See, just wait. 25 upon 4. Right. So that is equal to 25 upon 4, which is equal to 6.25. ठीक है? So 6.25. So value of CV is equal to 6.25. ठीक है? Joule per Kelvin. That's it. Obviously, you need not to write down the units, but answer is 6.25. Let's do the next question. 5 moles of an ideal gas at 293 Kelvin is expanded isothermally. Isothermally. So it means delta T is equal to 0. Okay. 5 moles ideal gas, N is equal to 5 mole. Temperature 293 Kelvin. from an initial pressure P1 2.1 megapascal, which is 2.1 into 10 to the power 6 Pascal, to 1.3 megapascal, which is 1.3 into 10 to the power 6 Pascal, at a constant external pressure, which is 4.3 megapascal, which is 4.3 into 10 to the power 6 Pascal, right? The heat transferred in this processes, we have to find out Q. So how to find out? See, isothermal process है. If the isothermal process, so it means delta U is equal to 0, है ना? Delta U is equal to 0. So delta U is equal to Q plus W. So we know that Q is equal to minus W, and minus W is minus P external delta V. Okay, so we can write plus P external delta V. So what is P external value? 4.3 into 10 to the power 6. 4.3 into 10 to the power 6. Now V2 minus V1. Delta V is equal to V2 minus V1. So how to find out V2 and V1? Simple. It's simple. We know that PV is equal to nRT. Right? So P1 V1 is equal to N 5 R and temperature 293. Okay, so V1 is equal to 5 RT upon P1. Okay, 5 RT upon P1. So you have to use this one. So this is 5 RT upon V2 minus 5 RT upon V1. Sorry, P1, P1 and P2. So we can say P2 minus P1. Now you have to put the values, right? You have to put the values over here, and when you put the values and solve, so you get the answer as 3 kilojoule. You get the answer as 3 kilojoules. So please do the calculation at home. So P1 is given, P2 is given, R ka value is given, temperature is given, everything is given. It's just you have to solve this. Clear? That's it. Now let's do next question. When 60-watt electric heater is immersed in a gas jar for 100 seconds, 60 watt, yani power is 60 watt, that is energy per unit time for 100 seconds. So it means energy associated with this electric heater, that is 60 into time, which is 60 into 100, which is equal to 6000 joule. Okay. In a constant volume container, yani delta V is 0, with adiabatic walls, it means Q is equal to 0. The temperature of the gas rises by 5 degrees Celsius. Delta T is equal to 5 degrees Celsius. So the heat capacity of the given gases. So it means we have to find heat capacity at constant volume, which is equal to the change in internal energy. So how to solve this? Delta U is equal to NCV delta T. So delta U is equal to 6000, right? Delta U, yani this is the energy. Okay. So 60 watt electric heater is immersed in a gas for 100 seconds in a constant volume container with adiabatic walls. The temperature of the gas rises by 5 degrees Celsius. So the heat capacity of the gases. So we have to take total energy as 6000. N is 1, CV is this, and delta T is 5. So CV is equal to 6000 upon 5. So on solving we get 1200 joule per Kelvin. Okay? So we get 1200 joule per Kelvin. So answer is going to be 1200. Answer is 1200. Fine. Now let's move to the next problem type. Now type 3 problem type, in which we are going to discuss some problems which are related to the work done. Right, so we can have different formulas for the work done in different process. Like for isothermal process, if we have reversible process, so we can use this formula minus 2.303 nRT log V2 over V1, or we can say minus nRT ln V2 over V1, or we can say minus nRT ln P1 over P2, right? So that is for reversible process. If we have the irreversible process, then we can say work done is equal to minus P external delta V. where delta V is equal to V final minus V initial. Now, this is for isothermal process, right? That is for isothermal process. Now, if we have the adiabatic process, so if we have adiabatic process, then what happens? Delta U is equal to W. So W, or we can say work done, we can find out with respect to internal energy change, which is equal to NCV T2 minus T1. NCV T2 minus T1, or what we can write, P2 V2 minus P1 V1 upon gamma minus 1, right? So what is gamma? Basically this is the ratio, right? Gamma is what? Cp over Cv. So for adiabatic, for reversible adiabatic process, we have these three conditions. Like PV की power gamma is equal to constant, it means P1 V1 gamma is equal to P2 V2 gamma. T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. T gamma P1 minus gamma, right? T1 V1, T1 or P1, it is equal to T2 gamma and P2 1 minus gamma. So these are the condition which holds true for the adiabatic process. So you have to learn this. You have to learn this. Right, so we can find out the work with respect to adiabatic by using this formula P2 V2 minus P1 V1 upon gamma minus 1, or NR upon gamma minus 1 T2 minus T1. So this is completely based upon the question, which formula you have to use. Okay, so let's start doing the question. So the question number 1 mole of an ideal monoatomic gas is subjected to changes as shown in the graph. The magnitude of the work done by the system or on the system is. So basically 1 mole of an ideal monoatomic gas, N is equal to 1 mole. It's ideal, so it means PV is equal to nRT, and it's a monoatomic gas, right? Monoatomic gas. So see how to solve this. So first we have 1 to 2 path, right? So work done 1 to 2 path, right? So that is at constant pressure. So constant pressure. So we can say that work done is equal to minus P external delta V, or we can say minus P delta V. So minus P, 1 pressure is equal to 1 and delta V. Here volume is 40, V final is 40 and V initial is 20. So we can say 40 minus 20, which is equal to minus 20 bar liter. Okay. Now for work done from 2 to 3, from 2 to 3. So this is at constant volume, right? So this is at constant volume. So at constant volume, work done is equal to 0. Work done is equal to 0. So now we need to find out the work done for 3 to 1. Work done for 3 to 1. So just see 3 to 1 process. So 3 to 1 process is this, right? So pressure changes very less. Here pressure is 1 and here pressure is 0.5. So pressure changes very less. Volume, initial volume is 40 and final volume is 20. So what we can say there, say that as pressure changes very less, so this is the reversible isothermal process, right? Reversible isothermal process. Why isothermal process? Because for isothermal process, PV is equal to nRT. So if I plot a curve in between pressure and volume, so we get the rectangular hyperbola. XY is equal to constant, right? So that's why it's a reversible isothermal process. And for reversible isothermal process, work done is equal to minus nRT ln V final upon V initial, which is minus nRT ln 20 by 40, right? 20 by 40, which we can write as 1 mole है 1 into R into T, right? R into T. So, okay, fine. ठीक है. So, we can say that N into, or we can say R into T, and this is ln 1 by 2, which is or we can say plus RT ln 2. Okay, plus RT ln 2. अब now how to solve this, मतलब how to find out the value of R and T, if it is given or not. So we have to find out something now, we have to find out something. So how to find out RT? So RT, we know that PV is equal to nRT na, PV is equal to nRT. So with respect to pressure and volume we can find out, with respect to pressure and volume we can find out R and T, right? So n ka value is 1, so we have to find out pressure and volume. So here pressure is 1, that is the pressure, right? That is the pressure, final pressure 1, and volume is 20, and final volume it is 20. So we can say that plus 20 ln 2, plus 20 ln 2. So on solving you get 20 into 2.3 log 2, 2.3 log 2. So ln 10 is 2.3 and log 2 is 0.3. So we have to take that only, 20 into 2.3 into 0.3. ठीक है, so on solving we get 13.8 bar liter. Now total work done, total work done, total work done is equal to minus 20 plus 13.8, that is bar liter, which is equal to minus 6.2 bar liter, 6.2 bar liter. Now we have to find out work done in joule. So 1 bar liter is equal to 100 joule. So if we have minus 6.2 bar liter, so that is equal to kitna? Minus 620 joule. So answer is 620. Answer is 620. Okay, fine. Now let's do next type of question. So it says 1 mole of ideal gas is allowed to expand reversibly and adiabatically. It means adiabatic heat is 0. N is equal to 1 mole. Reversible adiabatic process. From a temperature of 27 degrees Celsius. T1 is equal to 27 plus 273, which is equal to 300 Kelvin. Okay. Now work done is 3 kilojoule per mole. And final temperature of the gas we have to find, right? We have to find out the final temperature of the gas. So how to find out the final temperature of the gas? So for adiabatic process, work done is equal to delta U, or we can say N CV delta T. So work done is 3 kilojoule. So we can say 3 into 10 to the power 3 joules. N is 1. CV value, it is given 20 joule per mole per Kelvin, and delta T we have to find out. So what is delta T? That is equal to 3000 over 20, right? So 3000 over 20, we can say delta T is equal to 150 Kelvin, right? Delta T is equal to 150 Kelvin. So T1 is 300. Up see, T1 is 300. So T2 minus T1 is equal to 150, right? So here options are not given, here options are not given, right? Options are not given. So if I write down the correct options, so correct option may we have option 100 Kelvin, B 150 Kelvin, C 195 Kelvin, and D is equal to 255 Kelvin. So what is the correct option? Answer is B. Why? Because difference is 150, initial temperature 300. So T2 should be 150 only. Understood? T2 should be 150 only. So T2 minus 300, 150 है. The difference आना चाहिए ना. So that is going to be 150. Right? So if we see the option, it should be 150. Okay. Now let's do the next question. So in the next question, we have 5 moles of an ideal gas at 1 bar and 298 Kelvin is expanded into vacuum to double the volume, right? Vacuum, it means P external, external pressure, it is equal to 0. So the work done is, so what is work done? That is minus P external delta V. If the process is reversible, then we can say P external is almost equal to P internal, right? But if the process is irreversible, so P external is different. P external is not equal to P internal. right? So if external pressure is 0, so work done is equal to 0. So into vacuum to double the volume, the work done, that is equal to 0. It will expand automatically because there is no external pressure. So there is no need to do any extra amount of work, right? So answer is 0. Now let's do next question. The magnitude of work done by a gas that undergoes a reversible expansion. So we have reversible expansion, bete. Reversible expansion along the path ABC shown in the figure. So when we have this kind of question, reversible expansion and all, so see, area under the curve, area under the curve, it is equal to work done. It is equal to work done, right? So reversible has, so we can have two ways. We can have two ways, like we can say minus P dV. We can also find out the work in that way. But this is the easiest one. Area under the curve you have to find out in order to determine the actual work done. So see, here I am going to divide this into two parts. One is going to be AB and this one, write this AB, and here we can write E and F, right? So what is AB? 8 minus 2, 6, right? 6, and EB, it is going to be 8 minus 2, which is equal to 6. It means ABEF is the square. ABEF, it is equal to the square. Okay. Now BEC, if we talk about BEC, so BEC is going to be the triangle. Okay. So it means in order to find out the work, we need to find out the area of square plus area of triangle. Area of triangle. So area of square is going to be 6 into 6 plus area of triangle, half into base into height, and area of square ko we can write a square. So that is 6 ka square plus half. Base over here is this one. Which one? Let me show you. Base is this one, 12 minus 8, right? It is what? 12 minus 8. So 12 minus 8 is 4 and height is 6. So we can say 4 into 6. So it is 36 plus 2 2s are, so 2 6 are 12. So 36 plus 12, that is 48. So 48, only 48, right? So this is equal to Pascal meter cube. Pascal meter cube. So only the magnitude we have to find out, magnitude of work done. So that is equal to the 48. Clear? 48. Now let's do the next question. An ideal gas is allowed to expand from 1 liter to 10 liter. Yani initial volume is 1 liter and final volume is 10 liter against a constant external pressure of 1 bar. So work done in kilojoule is. So work done minus P external delta V weighted. So minus P external is 1, delta V 10 minus 1, which is equal to minus 9 bar liter. So minus 9 into 100 joule, 1 bar liter is equal to 100 joule we can take. So that is going to be the minus 900 joule, which is equal to minus 0.9 kilojoule. Okay. So we have to find out the work in kilojoule. So answer is going to be 3. That is equal to 0.9. That is equal to 0.9. Now let's do the next question. Consider the reversible isothermal expansion of an ideal gas in a closed system at two different temperatures T1 and T2. So T2 is greater than T1. Okay. The correct graphical depiction of the dependence of work on the final volume V. So see, reversible isothermal expansion. So we have to plot with respect to magnitude of work done with respect to final volume. It's a final volume V. Okay, so we can say that this is nRT ln V2 by V1, where V2 is equal to final volume and V1 is equal to initial volume. So let's solve. W is equal to nRT ln V2 minus nRT ln V1. So this is why ln V2 is the x, so nRT is the slope, and here this is going to be the intercept, right? This is going to be the intercept. Okay. So now if I say slope is equal to nRT, it means slope is directly proportional to temperature. Na? Slope is directly proportional to temperature. So in the question T2 is greater than T1, so it means slope at temperature T2 is greater than slope at temperature T1. Right? So if we see this, so answer is going to be the third one. ठीक है, आंसर इज गोइंग टू बी द थर्ड वन. ठीक है, सो दिस इज this. Clear? Because T2 slope is greater than T1 and it is going to be the straight line equation. It is going to be the straight line equation. So answer is 3. Okay. Now let's do the next question. The combination of plots which does not represent isothermal expansion of an ideal gas is. Combination of plot which does not represent isothermal expansion of an ideal gas. So ठीक है. So we have PVM molar volume. VM is equal to molar volume. It means volume of 1 mole of gas. So PVM is equal to RT. So pressure is equal to RT by Vm. So if I'm going to plot in between pressure and Vm, so I have to follow y is equal to mx plus c, which is the straight line equation. So this is true. A is true. Now pressure Vm, right? PVM. So PVM is equal to RT, na? That is the constant. So we have to compare this equation with xy is equal to constant. So we should be getting hyperbola curve, rectangular hyperbola. So this is the incorrect. Incorrect. Now PVM versus P at constant pressure, so obviously it is not going to change. So we get the parallel line to the x-axis. So this is true. Now U and Vm, right? Internal energy and Vm. So what about internal energy and Vm? So that's also incorrect. राइट आइसोथर्मल एक्सपेंशन है. सो फॉर आइसोथर्मल इंस्पेक्शन भाई इंटरनल एनर्जी क्या हो जाएगा, चेंज इन इंटरनल एनर्जी इज गोइंग टू बी जीरो. राइट, इट इज नॉट गोइंग टू चेंज बिकॉज इफ द टेम्परेचर, if you don't increase the temperature, so internal energy of the system cannot be changed, right? So which does not represent isothermal expansion of an ideal gas, because isothermal expansion के लिए तो internal energy zero है. So does not मतलब it means we have incorrect, so incorrect is going to be the B and D. Okay, so option 1 is going to be the right answer. Now we have discussed enough problems on the work done. Now we are moving to the next aspect of this chapter, and in the next problem type we are going to discuss some questions of the enthalpy, right? So in enthalpy, what is enthalpy? This is the heat change at constant pressure, or heat at constant pressure is enthalpy. That is going to be the delta H, right? If delta H is less than 0, that is for exothermic process, and if delta H is greater than 0, that is going to be the endothermic process. So we have some formulas which we have to use while solving the question over here. So first formula is delta H is equal to change in internal energy plus delta PV, right? That is going to be the work done. Okay. Then we have delta H is equal to delta E plus delta NGRT, right? Then if the pressure and volume both are variable, then we can say delta E plus P2 V2 minus P1 V1. If we have constant volume, then we can say delta H is equal to delta E plus V delta P. So we have these formulas which we have to use while solving the question. So let's do the question number 1. Enthalpy change for the adsorption process. So see, adsorption process. What? Adsorption process. So what happens in adsorption process? Some solute particles, they are getting adsorbed on the surface of the adsorbent, है ना? This is the part. This is the process. So adsorption process is the exothermic process because during the adsorption bond formation happens, right? Bond formation happens or bond is formed. So if bond is formed, so energy is released. So delta H is less than 0. Okay. Then we have the missile formation. So missile formation means what happens in the missile formation? So we have non-polar part is attracted to the non-polar part while the polar part is attracted to the polar part. So we have the aggregated form of the colloid which is missile formation, but for that energy is required and that's the endothermic process. So we can say option 3 is going to be the correct answer. ठीक है, missile formation, that's the endothermic process. Right? Energy is required for the missile formation. Now, let's do the next question. The number of endothermic process from the following is I2, if I say I2 to 2I, so here bond dissociation happens. So bond dissociation is endothermic. Endothermic. B, HCl gas is converted to hydrogen gas plus Cl gas in atomic form. That is also bond dissociation, endothermic. C, H2O liquid gives H2O gas. So that's the process of vaporization. So vaporization is also endothermic. Now D part. Carbon solid plus O2 gas gives CO2 gas. So that's the combustion process. So combustion process is exothermic. E part. Dissolution of ammonium chloride in water. So ammonium chloride dissociates in water. It's a dissociation reaction. So dissociation reaction, endothermic. So how many endothermic process we have over here? So we have 4 endothermic. 1, 2, 3 and 4. So answer is 4. Answer is 4. Okay. Now let's do the next question. For silver, Cp is equal to 23 plus 0.01 T. If the temperature of 3 moles of silver is raised from 300 Kelvin to 1000 Kelvin at 1 atm pressure, the value of delta H will be close to. So see, we know that delta H is equal to N Cp delta T. But we have Cp, right? In Cp we have temperature, right? As a variable. So what we can say, we write dH is equal to N Cp dt. And we have to integrate this. We have to what? Integrate this. So we get dH to delta H, we can say. Then we have N is equal to 3 mole. So N, in place of Cp, I can write 23 plus 0.01 T and that is dt. Okay. So we can say that it is going to be 3, N is equal to 3 and integration of 23 dt plus 3 integration of 0.01 T dt. And the limits are going to be 300 to 1000. Here also 300 to 1000. Okay. So what do we get on integration? Here we get 3, 23t and the limits are 300 to 1000. dt integration is t. Right. Up now next plus 0.03 and this is t square by 2. राइट टी है ना, सो टी का इंटीग्रेशन क्या हो जाएगा, टी 1 plus 1 है तो टी स्क्वायर बाय 2. सो हेयर वी राइट 300 और 1000. सो ऑन सॉल्विंग यू गेट 3 into 23 into 700, 100 minus 300, तो which is 3 into 23 into 700 plus 0.03 upon 2. So this is 10 to the power 3 का square minus 300 square. Okay. So on solving we get 61950 joules. 61950 joule, which is 61.9 kilojoule. So answer is going to be 162 kilojoule. Okay. Now let's do the next question. Okay. This is graph question. Consider the given plot of enthalpy of the following reaction between A and B. So A plus B gives C plus D. Identify the incorrect statement. Activation enthalpy to form C is 5 kilojoule per mole less than that to form D. So see, activation energy to form for the formation of C is equal to this. This is activation energy for the formation of C. So that is equal to 20 minus 5, which is 15. And activation energy for the formation of D, that is going to be 15 minus 5, which is 10. So it means activation energy enthalpy to form C is 5 kilojoule per mole more, not less. So this statement is false. Next, C is thermodynamically stable product. Yes, because energy of C is least. So this is thermodynamically controlled product. So this is true. Next statement, D is kinetically stable product. Yes, as activation energy is less, so D is formed in less time. So yes, D is kinetically stable product, which is also true. Formation of A and B from C has highest enthalpy of activation. Formation of A and B, formation of A and B from C. Yeah, that is going to be highest enthalpy of activation. So if I do the reverse reaction, if I want to form A and B from C, so enthalpy of activation is going to be itna, which is equal to 20. Yes, that is also true. So the incorrect statement is option number 1. Okay. Now let's do the next type of question. The difference between delta H and delta U when the combustion of 1 mole of heptane is carried out at a temperature T is equal to. So this is the reaction. Heptane is what? C7H16, CnH2n plus 2. That is the general formula for alkane. So this exists in liquid state, right? Smaller members of hydrocarbon, they exist in gaseous state. Then higher members liquid state, then more, if we have more carbon atoms, right, in the compound, then they exist in the solid state. O2 gas, so it is converted to CO2 gas and water liquid. So first we have to balance carbon, which is 7, then we have to balance hydrogen, and lastly we have to balance oxygen. So total oxygen 8 plus 14, right? So 14 plus 8, 22, so we write 11 O2. So delta Ng over here, it is going to be 7 minus 11, which is equal to minus 4. Okay, fine. So we have the formula delta H is equal to delta U plus delta NgRT. So we have to put this only. So delta H minus delta U is equal to delta NgRT. Delta Ng is minus 4. So answer is minus 4 RT. So if you check the option, you will get the answer. Okay, the answer is option number 1, minus 4 RT. Okay, minus 4 RT. So we have some simple question with respect to enthalpy wala part. Right. Now we are moving to the next problem type, and in the next problem type we are going to discuss the second law of thermodynamics, which is associated with the entropy and the entropy change. So what is entropy? The degree of randomness, right? If we have more randomness, then we can say more entropy. जैसे if liquid substance is converted to gaseous substance, so entropy increases. Why? Disorderliness increases. In the gaseous particle, we have very less force of attraction or negligible force of attraction. So we can say entropy increases. Right? Mixing, if we have the diffusion, in the diffusion process also entropy increases. So let's discuss some of the problems which are related to entropy, but we have certain formulas which we have to follow in order to solve the question. The first is delta S is equal to Q reversible over T, right? Q reversible over T. So if we have same temperature at constant temperature, how to find out the entropy? Q reversible by T with respect to heat energy, right? Now entropy change in a chemical reaction, total summation of the entropy of product minus summation of the entropy of reactants. Then for a process, we can have this formula delta S is equal to NCV ln T2 by T1 plus NR ln V2 by V1, or we can also say that Cp minus Cv is equal to R. So in place of Cp, if we put Cp, then we get another formula, delta S is equal to NCP ln T2 by T1 plus NR ln P1 by P2. Right, so these are the important formulas. Rest formulas are the derivation of these two formulas. Right, keep the temperature is constant. So T1 is equal to T2. So delta S it becomes NR ln V2 by V1. Right. So NR ln V2 by V1. ठीक है. So now let's discuss the question of the slot, right, or second law of thermodynamics. So let's discuss the question number 1. So the question number 1 says 1 mole of an ideal gas at 350 Kelvin is in a 2-liter vessel of thermally conducting walls. So thermally conducting walls, it means heat exchange in between system and surrounding is not equal to 0. Okay, so we have 1 mole of ideal gas and 1 mole ideal gas. So we have to follow PV is equal to nRT. Temperature that is equal to 350 Kelvin is in a 2-liter vessel. Volume is equal to 2-liter vessel, right? And Q is not equal to 0. Okay. It undergoes isothermal reversible expansion. It means dt is equal to 0 and it is expanded from 2 liter to 3 liter. So if I take V1 as 2 liters, so V2 is going to be 3 liter against a constant pressure of 4 atm. So P external is equal to 4 atm. So we have to find out the change in entropy of the surrounding. Okay, change in entropy we have to find out. So see how to do this question. So see, we know that delta S is equal to N Cv ln T2 by T1 plus Nr ln V2 over V1. Right, that is for the ideal gas. So dt is equal to 0. So we can say T1 is equal to T2. So if T1 is equal to T2, then this term, it is equal to 0. So we can say that delta S is equal to NR, NR ln V2 by V1. So N number of moles 1, R value is 8.314 and ln V2 3 upon 2. Right, so this is 3 upon 2. So we can say that 1 into 8.314 into 2.303 log 3 over 2. How to solve this? 8.314 into 2.303. So we can say log 3 minus log 2. Okay. So 8.314 into 2.303, log 3 is 0.4771 and log 2 is 0.3010. So now you have to solve on your own. It's just a calculation, and after when you solve it, so you get 3.378 joule per Kelvin, right? So that is going to be the answer. So we have to find out delta S. So delta S is equal to this 3.378. 3.378. Now nearest integer, we have to report in nearest integer. So the nearest integer is going to be 3. Okay, it is not 4, it is going to be 3. Okay, now let's do the next question. 30.4 kilojoule of heat is required to melt 1 mole of sodium chloride. So we have 1 mole of sodium chloride, that is 1 mole. So in order to melt this, we require heat energy equal to 30.4 kilojoule to melt 1 mole. And the entropy change at the melting point is delta S is 28.4 joule per Kelvin per mole at 1 atm. Okay, so we have to find out the melting point. So we know that if we have the process, so this process is called fusion, right? Fusion. So entropy change is equal to Q by T. Q by T, because here temperature is same. Temperature is same during the melting or during the boiling. Temperature it becomes constant. Okay, so delta S is given 28.4, Q is 30.4, but that is kilojoule, so we have to write 10 to the power 3, and T, where T is going to be the melting point, right? So we have to apply this. Okay, delta S is equal to Q by T. So on solving, we get 28.4 is equal to 3040, right, divided by temperature. So temperature is equal to 3040 divided by 28.4. So on solving, we get 1070.242 Kelvin. 1070.42 Kelvin. So this is going to be the melting point of 1 mole of NaCl solid. So obviously we write melting point of 1 mole, 2 mole, doesn't matter. Melting point of NaCl solid is this 1070.42 Kelvin. Okay. Now let's do next question. Which of the following relations are correct? So first relation, it is based on float bete. Float, so what is float? Change in internal energy is equal to Q plus W, and we have to write W as minus P delta V, right? So A is going to be incorrect. A is incorrect. Okay. Now let's check option B. So delta G is equal to delta H minus T delta S. Yes, this is correct relationship. We know this formula. So this is correct. Okay. Now see, delta S is equal to Q reversible by T. बिल्कुल सही. We have just used this formula. So this is also correct. Okay. Now fourth, D, delta H is equal to delta U. Delta U. And we have plus delta NGRT. Delta NGRT. But in the option we have minus delta NRT. So this is incorrect. So this is incorrect. So which are correct? So B is correct, C is correct. So answer is option number 2. B and C only. So they are correct. Okay. Now let's do the next question. During which of the following process does entropy decrease? Entropy decrease means randomness decreases. Randomness decreases. ठीक है. Freezing of water to ice at 0 degrees Celsius. So it means liquid water is converted to solid ice, right? So obviously randomness decreases because in solid particles are tightly packed, so they cannot move easily. So here delta S is going to be negative. Yes. Freezing of water at ice minus 10 degrees Celsius. Here also delta is negative. Freezing is negative, but freezing involves negative entropy change. Now here देखो N2 gas plus 3H2 gas gives 2NH3 gas. So here we have to find out delta Ng. So delta Ng is 2 minus 1 plus 3, which is equal to minus 2. So delta G is negative. So delta S is negative. Adsorption of CO and lead surface. It means we have the lead surface and there is the adsorption of carbon monoxide gas. So what happens? Entropy decreases. Entropy decreases because now CO or carbon monoxide gas particles, they cannot move here and there randomly. Dissolution of NaCl in water. So it means NaCl solid. If I add water in this, so we get Na plus aqueous and Cl minus aqueous. Here randomness increases, right? Here randomness increases. So here entropy change is going to be positive. Question says, during which of the following process does entropy decreases? So answer is going to be A, B, C, D. A, B, C, D. So answer is 1. Okay. Now let's do the next question. Okay. So same type of question. The process with negative entropy change. So if we see option number 1, the dissociation of calcium sulfate to calcium oxide and SO3 gas. So here solid substance is converted to gas, right? And which can increase the randomness, right? Disorderness. So here the delta S is going to be positive. Sublimation of dry ice. So dry ice means we have CO2 which is in solid form. So on heating or on removing pressure, what happens? CO2 is converted to gaseous particle. So again delta S is positive. Dissolution of iodine in water. Dissolution always, if we dissolve something, solid substance in water, so randomness increases. But because now the solid substance exists in the liquid state or aqueous state. Synthesis of ammonia from N2 and H2. So N2 plus 3H2, it gives 2NH3. So here delta Ng is equal to 2 minus 4 minus 2. So here delta H is going to be negative. Here entropy change is negative. So answer is going to be synthesis of ammonia from N2 and H2. Synthesis of ammonia from N2 and H2. Now next, the true statement amongst the following is both delta S and S are function of temperature. Both delta S and S are function of temperature. So see, simple hai na, delta S is what? Q reversible by T. So yes, it is dependent on temperature. If you increase the temperature, then randomness increases. Same goes with entropy na. Delta S is change in entropy. Change in entropy. And S is only entropy. So we know that randomness increases. Randomness is directly proportional to temperature. It increases. So both delta S and S, they are function of temperature. Yes, they are function of temperature. ठीक है? Okay. If we use this formula, delta S is equal to Q reversible by T, it means at same temperature, if you provide more heat energy to the system, then the randomness increases. Okay. ठीक है. Now let's do the next question. The process will be spontaneous at all temperature if. So we know that if we want to have the spontaneous process or feasible process, then delta G Gibbs free energy should be less than 0. Also we know that delta G is equal to delta H minus T delta S. So if delta H is negative and delta S is positive, then what happens? The first term delta H, it is going to be negative, and the whole term, second term, that is also going to be negative. So delta G comes out to be negative. So if delta H is less than 0 and entropy change is greater than 0, then at all temperature reaction is spontaneous. Then at all temperature reaction is spontaneous. Now let's do the next question. So next question says that the entropy change associated with the conversion of 1 kilogram of ice at 273 Kelvin to water vapor at 383 Kelvin is H2O solid, right? 273 Kelvin. So 1 kg of ice at 273 Kelvin is converted to water vapors at 383 Kelvin. So it means we have to write down a process. So first what happens? H2O solid is converted to H2O liquid, which is at 273 Kelvin only. And the entropy change for this process I am writing, that is for delta S1. Now then what happens? H2O liquid, right? H2O liquid, which is at 273 Kelvin, is converted to H2O liquid at 373 Kelvin. It means we just need to raise the temperature. Okay. So entropy change for this is going to be delta S2. Then H2O liquid is converted to the water vapors at 373 Kelvin. Okay. And entropy change for this is going to be delta S3. And then H2O gas at 373 Kelvin is converted to H2O gas at 383 Kelvin. Okay. So 383 Kelvin. So entropy change is for this process is delta S4. It means total entropy change is going to be delta S1 plus delta S2 plus delta S3 plus delta S4. So see, for delta S1, what is the process? Solid is liquid, solid is converted to liquid. So this is the fusion process. So we can say delta S1 is equal to delta H fusion by T. Okay. Now delta S2 may we are increasing the temperature, right? We are increasing our temperature. So here we have to use Cp ln T2 by T1. But here specific heat is given to, what is specific heat? Temperature, heat energy required to raise the temperature by 1 degree Celsius or 1 Kelvin, right? So that is specific heat capacity for 1 gram or for 1 kg. We have to understand that thing. So here we can write MS ln T2 by T1. Now delta S3 again vaporization process. So here delta S3 is going to be delta H vaporization divided by T. And delta S4, how to calculate? Again Cp ln T2 by T1, or we can say Ms ln T2 by T1. Here mass of ice is fixed. Mass is fixed, that is equal to 1 kg. So here if I write delta H1 is equal to delta H fusion by T. So delta H fusion is heat of liquid fusion and vaporization of water are 334 and this is 2491. So this is equal to 334 divided by 273 and the vaporization one which is delta S3 which is equal to 2491 divided by 373. Okay, 2491 divided by 373. Now plus delta S2. So delta S2 mass is 1. Specific heat for liquid water is 4.2 and ln T2. T2 is 373 divided by 273 and here also we have to write 1 into 2. Everything is kilojoule. Everything is in kilojoule and kg. So there is no need to convert kilojoule into joule or kilogram to gram, right? So there is no need to do that. So here 1 into 2 ln 383 upon 373. Now so you have to solve, right? So after solving you get the answer equal to 9.26. Right, you get the answer equal to 9.26. So 9.26 kilojoule per kg per Kelvin. Okay, kilojoule per kg per Kelvin. So that is going to be the answer. Okay, now let's do the next question. Two blocks of the same metal, having same mass. So we have two blocks, same mass m, and another block mass m. Okay. Temperature, initial temperature T1 and here initial temperature T2. That is the initial temperature. Now, when they are brought in contact with each other and they are allowed to attain the thermal equilibrium. So, after thermal equilibrium, what happens? Here TF is equal to T final is equal to T1 plus T2 divided by 2. And here also T final is T1 upon T2, T1 plus T2 divided by 2. Thermal equilibrium, yani temperature is going to be same. At constant pressure, now we have to find out change in entropy. So how to find out change in entropy, right? So see, suppose entropy change for this block is delta S1 and entropy change for this block is delta S2. So total entropy change is delta S is equal to delta S1 plus delta S2. Delta S को we can write Cp ln T final upon T initial. Similarly for delta S2 we can write Cp ln T final upon T initial because pressure is constant at constant pressure. That's why we are writing Cp. In the above question, we have the same thing because the pressure is constant, right? So Cp. So what we can write Cp ln, right? So on solving this, what we can write Cp common. Let's take Cp common. So we can say Cp ln. This is going to be Tf square upon T initial hai. So here it is T1 and here it is T2. Okay, so we can write T1 plus T2. Is it clear? Okay, T1 plus T2. Okay, now let's put the value of Tf. So delta S is equal to Cp ln Tf square upon T1 plus T2. We have used this identity. Log A plus log B is equal to log A dot B. So we have used this identity over here. So now let's put the value of TF. So TF is Cp ln T1 plus T2 ka whole square and divided by 2 ka square and here T1 plus, or we can say T1 T2. Here in the denominator we have to write T1 and T2, not T1 plus T2, T1 and T2. Okay. So this is going to be Cp ln T1 plus T2 square upon 4 T1 and T2. Here we have to use this multiply, na? We have to do the multiplication. So we have to write TF square T1 and T2. Okay, we have to do the multiplication. That's it. So if we see, so the correct answer is option number A. Okay, so that's it for the this problem type. So we have discussed enough question related to entropy. Now our next problem type is related to the Gibbs free energy. Gibbs free energy is basically used to discuss the spontaneity of the reaction or feasibility of the reaction. So for this spontaneous process, delta G is always negative, right? For spontaneous process, delta G is going to be negative. Then we have certain formula for that, right? Formula for that. Like we can relate delta G with the equilibrium constant. So therefore, we have certain formula. Delta G is equal to delta H minus T delta S. Then we have delta G is equal to delta G naught. Okay, delta G naught or plus 2.303 RT log Q. Okay, so at equilibrium, delta G is equal to 0. So we can write delta G naught is equal to minus 2.303 RT log K equilibrium. And how to calculate K equilibrium? How to calculate? So K equilibrium is the product की concentration raised to power its coefficient divided by reactant concentration raised to power its coefficient. So in that way we can find out the K equilibrium. So we have these formulas, right? So on the basis of these formula, let's discuss the question. So question number 1. The value of log K for the reaction A gives B at 298 Kelvin is. So you have to report the answer in nearest integer. Delta H naught is given, delta S naught is given, and you have to take 2.303 into 8.314 into 298 as 5705. So we have to find out log K. So we have one formula. Delta G naught is equal to delta H naught minus T delta S naught. Now we have one more formula which relates delta G naught with the equilibrium constant, and that is minus 2.303 RT log K equilibrium. So that is delta H naught minus T delta S naught. Now this value, because temperature is 298, so this value we have to write as 5705. So log K we have to find. Delta H naught is minus 54.07. So this is minus 54.07 into 10 to the power 3, because delta H is in kilojoule. So we have to convert this into joule. Or delta S naught is 10 joule per Kelvin. So we can write minus 298 into 10. Okay. So when you solve this, you get 5705 log K, okay, which is equal to minus 57050 once you solve it. Okay. So log K is equal to minus 57050 divided by 5705, which is equal to 10. Okay. So the value of log K is 10. So you have to report the answer as 10. Okay. Fine. Now let's do the next question. Consider the graph of Gibbs free energy versus the extent of reaction. Extent of reaction means कि reactants are converted to product in that way. Okay, so the number of statements from the following which are true with respect to points A, B and C is. See, if we have the Gibbs energy curve, so we know that कि if Gibbs free energy, or we can say change in Gibbs free energy, is going to be negative, right? So the reaction is spontaneous, right? And if the Gibbs free energy change is positive, then the reaction is non-spontaneous. So we have to apply this rule in order to understand the various statements. So the first is reaction is spontaneous at A and B. So देखो CA. Fine. Because after A, Gibbs free energy decreases, right? Gibbs free energy decreases. So we can say at this point, A point, we can say delta G is less than 0. So yes, it is spontaneous. But if we talk about B, so B pay for some time, right? Delta G, any change in delta G, that is equal to 0. So it means at B we have equilibrium. Okay, at B we have equilibrium. So reaction is spontaneous at A and B? No, this is false. Reaction is at equilibrium at point B? Yes, it is true. And non-spontaneous at point C. So if you see point C, so point C, so here Gibbs free energy is going to be positive because it is moving in upward direction. The curve is moving in upward direction. So we can say that reaction is spontaneous at point C. Yes, because delta G comes out to be positive. So this statement is true. Now next, reaction is spontaneous at A. True. And non-spontaneous at C. This is also true. Reaction is non-spontaneous at A and B. No, at B pe the reaction is at equilibrium, right? At B pe it is equilibrium. So this is false. So number of correct statements, right? So the number of statements from the following which are true. So true statements total 2. So answer is 2. Now let's do the next question. For the complete combustion of ethene, okay, the amount of heat produced as measured in bomb calorimeter. Bomb calorimeter means constant volume, right? Calorimeter. So calorimeter is we can say it is that setup in which we can measure the heat capacity, right? In which we can measure this. So amount of heat produced as measured in bomb calorimeter is itna heat produced, yani QV that is produced है तो -1406 kilojoule per mole. Temperature is 300 Kelvin. Okay. So the minimum value of T delta S needed to reach equilibrium is. So we know that at equilibrium, delta G is equal to 0. So if delta G is equal to 0 at equilibrium, then how to solve this? Delta G is equal to delta H minus T delta S. So if delta G is 0, so we can say that delta H is equal to T delta S. Right? Up now, see, we have QV given. Okay, fine. So now how to solve this? How to solve this? See, fine. QV है, so QV को we can also write delta U. Heat at constant volume is the change in internal energy. Now delta H को we can also write delta U plus delta NGRT is equal to T delta S. Okay. So delta U is equal to -1406 kilojoule. So -1406 into 10 to the power 3. And delta Ng we have to find out. So delta Ng is equal to 2 minus 3. So 2 minus, right, that is going to be 2 minus 3 which is equal to -1. That's it, 2 minus 4 not 3. Yeah, 2 minus 4 not 3 because ethene is also a gas. So 2 minus 4 which is equal to -2. Okay, fine. ठीक है. So that is going to be -2 into 8.314 and temperature, right? So what is the temperature? 300 Kelvin. Okay, so 300 Kelvin. So in that way we can find out the enthalpy. Now we have to find out this temperature. Now we have to find out this temperature because for this temperature, right, if delta H is equal to T delta S, then we can say it is at equilibrium. So we have to find out this temperature. Okay, find out this temperature. So let's do it. So on solving now, when you solve this thing, you get answer equal to total answer. Okay. एक मिनट, just give me a moment. We have to find out the value of T delta S now only. So basically not temperature we have to find out. We have to find out T delta S. So on solving now, you get -411 kilojoule. Right? So answer is going to be -411 kilojoule. That's it. So T delta S value is 1411. Okay, kilojoule, that is the answer. Okay, now let's do the next question. The incorrect statement from the following is, so first, the electrical work that a reaction can perform at constant pressure and temperature is equal to Gibbs free energy. So we have already discussed in the class, right? Like Gibbs free energy change is actually equal to the useful work, and useful work is basically non-expansion work, and electrical work is actually non-expansion work, है ना? Non-expansion work is the electrical work. So basically this statement is true. Now second, E naught cell is dependent on pressure. No, no. E naught cell does not depend on pressure, right? Does not depend. So this is false. Now third is d E naught cell upon dt. So d E naught cell upon dt, that is equal to the temperature coefficient. And if it is equal to the temperature coefficient, so we know that it is equal to delta S naught upon LF. That's the formula. So this is also true. Now see option number D. A cell is operating reversibly if the cell potential is exactly balanced by the opposing source of potential difference. Yes, it is true. If the cell potential, right, it is balanced by the opposing source of potential, then we can say the reaction is the reversible reaction, or we can say cell is operating reversibly. Okay. So yes, this is also true. So the incorrect statement from the following is B. The option B is the answer. Okay. Now let's do next question. So next question is, ठीक है, FeO2 minus it gives FeO2 minus Fe3 plus. Let me rewrite this. FeO2 minus, so oxidation state over here is x minus 8 is equal to minus 2, which is x is equal to plus 6, right? Oxidation state of oxygen is minus 2, so we can say x minus 8 is equal to minus 2, which is going to be x plus 6. So it is converted to Fe3 plus. So for plus 6 to plus 3, so there is a change of 3 electron, right? And E naught cell is equal to plus 2.2 volt. Okay, now we have Fe3 plus converted to Fe2 plus. So here 1 electron. So here E naught cell is equal to plus 0.70 volt. And we have to find out the value of FeO2 minus gives Fe2 plus. It means 4 electron. E naught cell we have to find out for this one. And now we know that because if we add these two reactions, so we get this reaction, desired reaction. E naught cell is intensive property, hence cannot be additive or subtractive. So how to solve this question? We can solve this question if we calculate delta G value, right? Delta G. Suppose for this reaction, for the first reaction, this is delta G naught 1, and for second reaction delta G naught 2, and this for delta G naught 3, right? So delta G naught we can calculate by minus NF E naught cell. Okay, so delta G naught 3 is equal to delta G naught 1 plus delta G naught 2, right? Now delta G naught 3, how to solve? Minus 4 into F into E naught cell. For delta G naught 1, number of electrons change is equal to 3. So that is equal to minus 3 into F into 2.2 plus 1 into 0.70. So we can say minus 1 into F into 0.70. Okay. So when we solve this, so see, we can cancel this Faraday, we can cancel, right? So we have minus 4 E naught cell, which is equal to minus 3 into 2.2 minus 0.70. So E naught cell is going to be minus 6.6 minus 0.70 divided by 4. Okay, divided by 4, and when you solve this you get answer equal to 1.825. But we have to report the answer in terms of 10 to the power minus 3. So it is equal to 1825 into 10 to the power minus 3, which you can compare with x into 10 to the power minus 3. So here answer is x, which is equal to 1825. Okay, now let's discuss the next question. Let's discuss next question. Okay, A gas, it gives 2B gas plus C gas. So question says, for the given reaction, if the initial pressure is 450 mm of Hg. Okay, initial pressure. So T0, at T is equal to 0, initial pressure is due to the A gas, which is equal to, wait, yeah, which is equal to 450 mm of Hg, right? 450 mm of Hg. Now after some time what happens? 450 minus x, because the coefficient of A is 1. Then we have 2x and then x. And question says, and the pressure at time t, it is 720 mm of Hg at constant pressure and constant volume. It means total pressure at time t is 450 minus x plus 2x plus x, which is equal to 720. So we can solve for x. So x is going to be 720 minus 450 divided by 2. And when you solve this, you get x is equal to 135. Okay. Now the fraction of A decomposed under these condition is x into 10 to the power minus 1. So fraction of A decomposed is equal to decomposed amount of A divided by total amount of A, right? So that is 135 and initial we can say 450. So when you solve this, you get 0.3 as the answer, and which is equal to 3 into 10 to the power minus 1. Okay. So you have to report answer in terms of x into 10 to the power minus 1. So x value is actually equal to 3. Okay. Now let's do the next question. Assuming ideal behavior, the magnitude of log K for the following reaction is this. Fine. The value of x's. So we have to find out the value of log K. Okay. So how to find out the value of log K? See, Gibbs free energy, they are given to us. So we know that delta G naught is equal to minus 2.303 RT log K. So log K is equal to delta G naught upon minus 2.303 RT. Okay. Delta G naught of reaction is not given, right? Delta G naught of reaction is not given. So what we are going to do? We are going to calculate delta G naught of reaction. How? Summation of delta G naught of products minus summation of delta G naught of reactants. Okay. So products में we have liquid का, तो liquid का it is given minus 1.24 into 10 to the power 5. So what we can say, this is minus 1.24 into 10 to the power minus 5. Then minus 3 into Gibbs free energy change is minus 2.04 into 10 to the power 5. That is per mole. Okay, that is per mole. Okay, fine. So when you solve this, so you get answer equal to minus 1.24 into 10 to the power 5, and this is going to be plus. So 3 4s are 12, 3 0 1, 3 2s are 6. So 6.12 into 10 to the power 5. So you get answer equal to 4.88 into 10 to the power 5. Okay, 4.88 into 10 to the power 5. Now what to do? Next, we have to put delta G naught value over here. So log K is equal to delta G naught upon 2.303 RT Okay, so delta G naught is 4.88 into 10 to the power 5, 2.303. R ka value we have to take as 8.314. Fine, 8.314, and temperature is 25 degrees Celsius. So 25 plus 273, which is equal to 298 Kelvin. Okay. So when you solve this, you get answer equal to 855. Okay, you get answer equal to 855. Fine. 850. Acha, ek minute. 855 into 10 to the power minus 1. Wait. So you get answer equal to 855 into 10 to the power minus 1. Okay. 855 into 10 to the power minus 1. That's the answer. So value of x is 855. Clear? That's it. Now let's do the next question. For a chemical reaction, A plus B is in equilibrium with C plus D. Okay. So delta H naught of reaction is given, that is 80 kilojoule per mole, and delta S naught depends on temperature, and delta S naught of reaction is 2T, which is in joule per Kelvin per mole. Okay. So minimum temperature at will it becomes spontaneous. So see, in order to solve this question, just take the process at equilibrium. So if the process is at equilibrium, so we can say 0 हो जाएगा ना. So we can say delta H minus T delta S. So delta H is equal to T delta S. So if we consider the process at equilibrium, then we can find out the temperature at which the system is at equilibrium, at which the reaction is at equilibrium. Now what is the next step to do the question? Because if the temperature is more than that temperature, if the temperature is more than this temperature, right, then delta G is going to be negative and the reaction is going to be the spontaneous. So let's find out this thing. So delta H is 80 into 10 to the power 3, and this is T and this is 2T. Okay. So it means 80 into 10 to the power 3, which is equal to kitna? 2T square. So T square is equal to 40 into 10 to the power 3, which we can write as 4 into 10 to the power 4, and T is equal to under root 4 into 10 to the power 4, which is 2 into 10 to the power 2 and 200 Kelvin. Okay. So the question says depends on the temperature. Minimum temperature at will it become spontaneous. So minimum temperature at will it become spontaneous, that is going to be the 200 Kelvin, and above 200 Kelvin, reaction is spontaneous. Reaction is spontaneous. Okay. Now let's do next question. For the dimerization reaction, okay, so for the dimerization reaction, 2A gas, it gives A2 gas at 298 Kelvin. Delta U naught is given and delta H naught is given, and we have to find out delta G naught. So how to find out? So we know that delta G naught is equal to delta H naught minus T delta S naught, and delta H naught is equal to delta U naught plus delta NGRT. So delta U naught is kilojoule, so minus 20, okay, into 10 to the power 3. Delta Ng is 1 minus 2, which is equal to minus 1. 1 minus 2. So this is minus 1. R का value is 8.314 and temperature is 298. ठीक है? So on solving, you get value minus 22477.57 joule. Okay, now you have to put this value into this equation, that is minus 22477.57 and minus 298, and delta S naught is minus 30. So when you solve this, you get minus 13537.57 joule. Okay, so basically answer is going to be minus 13537. Okay, that's it. It's just the calculation, right? You have to solve it. Now next question. This is a good question. The variation of equilibrium constant with temperature is given below. ठीक है, we have T1 temperature, we have T2 temperature. So T1 25 degrees Celsius means it is 298 Kelvin and this is 373 Kelvin. Okay, so K1 is given, K2 is given. So values of delta H naught, delta G naught at T1 and delta G naught at T2. So how to find out? So see, delta G naught at T1 temperature, how to find? Minus 2.303 RT log K1. So minus 2.303 into 8.314, temperature 298 and log 10. Log 10 is equal to 1. So minus 2.303, 8.314 into 298. So when you solve this, you get answer equal to minus 5.705. ठीक है, तो basically answer is going to, एक मिनट, answer is minus 5705.8. That is joule, so we can write minus 57.05 kilojoule. Okay, minus 57 point, we can write minus 57.05 kilojoule. Okay, bete. Now similarly, you can find out delta G naught at T2. How? Minus 2.303 into 8.314 into 373 into log 100, or we can say log 10 to the power 2. So on solving, you get minus 14.28 kilojoule. Okay, minus 14.28 kilojoule. Now our task is to find out the enthalpy. So if different temperature is given, then we have to use this. Log K2 by K1 is equal to delta H upon 2.303 R 1 by T1 minus 1 by T2. So this equation we have also discussed in the chemical kinetics, right? So when we have two equilibrium constant at different temperature, then we have to use this formula. So when you put everything like log 100 divided by K1 is what? 10, right? Log 100 by 10. So when you solve everything, delta H upon 2.303 R को you can write 8.314, and we have to find out in kilojoule. So 8.314 divided by 1000 कर दिया, so that it is converted to kilojoule वाला part. 1 minus 298 and 1 minus 373. So when you solve this na, so you get answer equal to 28.4 kilojoule per mole. 28.4 kilojoule per mole. So basically the answer is 3. Okay, so the answer is going to be third option. That's it. Now let's do the next question. Next question says, for a reaction 2M plus NO2, it gives N2ON. ठीक है, the free energy change is plotted as the function of temperature. यानी delta G is plotted as a function of temperature. Fine. So we know that delta G is equal to delta H minus T delta S. So we can say Y, and this is X. Delta S is going to be slope and this is going to be intercept. ठीक है, so intercept is equal to delta H and slope is equal to delta S. So slope is going to be negative, so we have the negative slope. Fine. So the temperature below which the oxide is stable. So temperature below which the oxide is stable could be inferred from the plot as the point at which. Question says temperature below which the oxide is stable. It means oxide should be stable. If the oxide should be stable, it means reaction moves in the forward direction. And if reaction moves in the forward direction, then what happens? The slope changes from negative to positive. Is it true? The slope changes from negative to positive. So see, slope is delta H. So if oxide is stable, then we can say reaction moves in the forward direction. Right, reaction moves in the forward direction. So what happens? Yes, slope should change from negative to positive, because if the slope changes from negative to positive, then delta S becomes positive, and that is for the spontaneous process. That is for the spontaneous process, right? So we can do it that way. In that way you can do this question. So answer is the slope changes from negative to positive. Yes, it's true. ठीक है. Now next question. For the reaction A liquid gives 2B gas. Okay. Delta U is given, delta S is given, and hence delta G in kilocalorie. So how to find out? See, first so delta H is equal to delta U plus delta Ng RT bete. So delta U is 2.1 kilocalorie है, तो into 10 to the power 3. Delta Ng 2 only. R in calories 2, temperature is 300, right? So when you solve this, you get 3300 calorie. Now, what is the next step? So we have to put over here delta G is delta H minus T delta S. So 3300 minus 300 and delta S is 20. So it is going to be 3300 minus 6000, which is equal to minus 2700 and minus 2.7 kilocalorie. So answer is minus 2.7 kilocalorie. Okay, so obviously you have to report the answer as 2.7 if it is the integer type, otherwise minus 2.7 kilocalorie. Now next question, the incorrect match in the following. Incorrect. Delta G naught is less than 0, it means reaction is spontaneous. So if reaction is spontaneous, then equilibrium constant value should be high. It should be high. So it means this is the correct. If delta G naught is equal to 0, then K का value is 1. बिल्कुल सही, because log 1 is equal to 0. So if log 1 is equal to 0, then delta G naught is minus 2.303 RT log 1, which is 0. So delta G naught is 0. So this is also true. If delta G naught is greater than 0, it means reaction is non-spontaneous. And if reaction is non-spontaneous, the value of K equilibrium is less. So this is also true. Now, delta G naught is less than 0, it means reaction is spontaneous. So, K equilibrium is less than 0 or less than 1. No, it should be greater than 1, right? So, this is the incorrect part. Incorrect part. So, it means option D is the correct answer or option 4 is the correct answer. Okay. Now, let's do the next question. A process has delta H is equal to 200 joule per mole and delta S is equal to 40 joule per Kelvin. Out of the values given below, choose the minimum temperature above which the process will be spontaneous. In order to do this, what we are going to assume? Assume equilibrium process, right? Equilibrium. So delta G, matlab we can write delta H is equal to T delta S, right? Delta H is 200, T into 40. So temperature is 200 upon 40, which is equal to 5 Kelvin. So the minimum temperature above which the process will be spontaneous, that is 5 Kelvin, because see, delta G is equal to delta H minus T delta S. So delta H is 200. If I say 5 into 40, so that is equal to 200 minus 200. So when you increase the temperature, then delta G comes out to be negative or less than 0, right? So above, this is the minimum temperature above which the process is going to be spontaneous. So answer is going to be option number C. Now let's do the next question. Okay, for a chemical reaction X gives Y. The standard reaction gives free energy depends on temperature as this. Okay, fine. Let's do this. So delta G naught is equal to delta H naught minus T delta S naught. So we have to compare this with this 120 minus 3 by 8T, right? 120 minus 3 by 8T. So delta H naught is 120 and delta S naught is 3 by 8. Delta S naught is 3 by 8 and delta H naught is 1 by 20. Okay. So the point is that question says the major component of the reaction mixture at T is. Major component of the reaction mixture at T is कि whether X is in major amount or Y is in the major amount. So the point is, if the reaction is spontaneous or reaction moves in the forward direction, then Y is going to be in major amount. And if the reaction is non-spontaneous and reaction moves in the backward direction, then what happens? We can say X is going to be in the major amount. So we have to do in that way only. So suppose we have option is T is equal to 300 Kelvin. So first let's check option number 1. So 120 minus 3 by 8, right? 120 minus 3 by 8 into 300. Right. So when you solve this, so you get certain, obviously you get certain value, right? You get certain value. So ऐसे similarly when you solve this second वाला part 120 minus 3 by 8 into 280. Now you have to solve for C part 120 minus 3 by 8 into 350, right? 350. Now then you have to solve for fourth part. You have to solve for fourth part, that is 120 minus 3 by 8 into 315. 315. Okay, so when you solve for 280 wala part, so value is going to be 15, around 15, right? And when you solve for 300 wala part, you get value as 1.875. So reaction is going to be least positive. Reaction is going to be least positive over here. So see, if we solve for third one, we get minus 11.25. So here delta G is negative. It means reaction is spontaneous. And if reaction is spontaneous, then we have more amount of Y. Right? We have more amount of Y. Up now here reaction is positive. It means reaction is not spontaneous or reaction moves in the backward direction. So it means we have more amount of X. Here it is also positive, then we have more amount of X, not Y. Here it is positive, then we have more amount of X, not Y. So if we see the correct option, or if we see the option, so here X should be in major amount. Here X should be in major amount. Here X should be in major amount and here Y should be in major amount. So which is the correct one? Obviously option number 4, and that is going to be the correct answer. Okay. Now let's do the next question. MgO plus 2 carbon, not 2 carbon, only 1 carbon, gives Mg solid plus Leo gas for which delta H is given, delta S naught is given, is not feasible at 298 Kelvin. Temperature above which reaction will be feasible is. Same, you have to consider delta G naught as 0, or we can say delta H naught is equal to T delta S naught. And when you put all the values, you can find out the temperature, and the temperature is going to be 2480.3 Kelvin. Please solve this on your own. So that is option number 3. That is going to be the correct answer. Now, next, the standard Gibbs free energy for a chemical reaction at an absolute temperature T is given by this. So delta G naught is equal to delta H minus T delta S naught. Okay. So delta H is A and delta S naught is B. Okay. So A and B are non-zero constant. Okay, fine. Which of the following is true about the reaction? Exothermic reaction B is less than 0. B is entropy. So entropy and enthalpy doesn't relate like this. So it is incorrect. Endothermic, if A is 0, yes, if A is 0, if delta H is greater than 0, then it is endothermic. So this is true. Endothermic, if A is less than 0, no. Exothermic, if A is greater than 0, no. So option 2 is the correct answer. Okay. Now let's discuss another problem type which is based upon the calorimetry, right? So in the calorimetry, we generally find out the heat at constant volume, right? Or we can say heat capacity at the constant volume. So let's do the question of this type. So question says 0.3 gram of ethane undergoes combustion at 27 degrees Celsius. Ethane, we have ethane. Ethane is what? C2H6, and it undergoes combustion. So it gives CO2 plus H2O. So we have to balance this 2CO, 3H2O and then 3 0.47 by 2 O2. Perfect. So this is 0.3 gram of ethane. Temperature is 27 plus 273, which is 300 Kelvin. In a bomb calorimeter, yani constant volume, the temperature of calorimeter system, including the water, is found to rise by 0.5 degrees Celsius. So delta T is 0.5 degrees Celsius. The heat evolved during combustion of ethane at constant pressure is, oh, so we have to find out delta H or QP in kilojoule per mole. Heat capacity of calorimeter system is given, that is we can say CV is given 20 kilojoule per Kelvin, and R ka value we have to take 8.3 joule per Kelvin per mole. Perfect. So how to solve this? So first we have to find out number of moles of ethane, right? First we have to find out delta U na, and delta U is what? NCV delta T. But we have to find out delta U per mole. So it means we have to find out per मोल होगा ना, तो for n मोल cv delta t है, तो पर मोल के लिए we are going to say cv delta t upon n. ठीक है. So molar mass is equal to 2 into 12 plus 6 into 1, which is equal to 30, and number of moles is 0.3 upon 30, which is equal to 0.01. ठीक है. So if I solve delta u from here, so delta u per mole, it is equal to cv is 20 kilojoule into delta T 0.5, and heat evolved, right? So we have to write minus. Heat is evolved, so we have to write minus, and minus indicates heat evolved. Okay, now n is 0.01. So when you solve this, you get minus 1000 kilojoule, right? Ab now next step, delta H is equal to delta U plus delta NGRT. Now you have to find the value of delta NG only. So let's find out the value of delta NG. So this is gas, this is liquid, this is gas, this is gas. So this is going to be 2 minus 1 plus 7 by 2, right? Delta NG is equal to 2 minus 1 plus 7 by 2. So when you solve this, you get answer equal to minus 2.5. You get answer equal to minus 2.5. So it's just you have to put everything over here. Delta U is minus 1000. This is minus 2.5. R is 8.3. We have to find in kilojoule. So 8.3 divided by 1000. So that R ka value we can convert into kilojoule into 300. So on solving we get 1006.25. Right? 1006.25. So we have to report in nearest integer. So we have to write 1006. Okay. Now let's do next question. The reaction of cyanamide with oxygen was run in a bomb calorimeter, and delta U was found to be this, and magnitude of delta H 298 for this reaction is. Fine. It's very simple. What to do over here? Means how to solve this question? It's very simple. See, delta U is given minus 742.24 kilojoule per mole. Okay, and we have to find out delta H. So delta H is what? Delta U plus delta NGRT. Delta U is minus 742.24, but it is in kilojoule. So we have to find delta NG first. So acha na, just try to write the correct equation. It is CO2. ठीक है. So delta NG is going to be 1 plus 1 minus 3 by 2. So 2 minus 3 by 2, which is equal to 4 minus 3 by 2, right? Let me rewrite this. So we get 4 minus 3 by 2, which is equal to 1 by 2, right? So 1 by 2, answer is 1 by 2, matlab not answer, that delta NG, and R ka value you have to take as 8.314, and temperature you have to take as 298, right? So you have to take the temperature as 298. It just now you have to solve the question. So when you solve this, so we can say minus 742.24 plus 8.314, and here we can say 2 ones are 2, 2 4s are 8, 2 9s are 18. ठीक है, so 8.314 into 149, and on solving, so you get the answer. So you get the answer equal to how much? That is equal to, I have to solve this. So wait, minus 742.24 plus 8.314 into 149, right? So that is 496.54, right? So you get the answer equal to, please write it down, that is 8 what? Minus 742, and that is plus है ना 8.314, and here we have 1000 also na, divided by 1000, because this is in Joule. When you divide this by 1000, so you can convert this into kilojoule, and on solving you get minus 743.47, right? 743.47, that is the answer, that's kilojoule. Okay, that's it. ठीक है, so we are now moving to the next problem type, that is the last problem type, and in which we are going to discuss some questions which are related to thermochemistry. And in thermochemistry we actually do the enthalpy change for a reaction. Okay, enthalpy change for a reaction. So let's do the question. Before doing the question, we have certain formulas which are important, right? This is the Kirchhoff's equation. So enthalpy is dependent on the temperature. So we can find out enthalpy change at different temperatures. Just this is T2, and enthalpy at T1 change divided by T2 minus T1, which is equal to delta Cp, or molar heat capacity at constant pressure, right? So this formula is derived on the basis of this only, delta H is equal to Ncp delta T. Delta H is equal to Ncp delta T. Similarly, we have this delta U is equal to Ncv delta T, right? So on the basis of this, now on this we are going to solve question, right? So please learn it, please memorize it, we will apply this. Now let's discuss the question number 1. So question number 1 says, consider the following data. Heat of combustion of H2, it is equal to minus 241.8 kilojoule per mole. Heat of combustion of carbon, it is this. Heat of combustion of liquid ethanol is this. So heat of formation of C2H5OH we have to find out. So first you should know how to write down the heat of formation of reaction. So this is C2H5OH liquid. So this is formed from carbon, hydrogen and oxygen from the element in their standard state. Now we have to balance this. So 2 carbon, 3, and oxygen we will write half. ठीक है? So element in the standard state, and we have to produce only 1 mole of the substance. So that is equal to enthalpy of formation. Now if I want to find out the enthalpy of formation from the combustion, or we can say enthalpy of reaction from the combustion reaction, then that is going to be the summation of enthalpy of combustion for reactant minus summation of enthalpy of combustion for product, right? So if I use this na, तो reactant का carbon का enthalpy 393.5, तो we can say minus 2 into delta H naught combustion of carbon. Okay, ठीक है, or we can say, let me rewrite this. So we can say delta H naught reaction is equal to summation of enthalpy of combustion of reactant minus summation of enthalpy of combustion for products. ठीक है, so here 2 into enthalpy of combustion for carbon plus 3 into enthalpy of combustion for hydrogen, then oxygen ka there is no need to write down the enthalpy of combustion, then minus product ka C2H5OH, right? So enthalpy of combustion of C2H5OH. So now we have to put all the values. So that is going to be minus 2 into 393.5. ठीक है, H2 का minus 241.8, तो we can say minus 3 into 241.8. So minus 1 into minus 1234.7, minus 1234.7, right? So when you solve this, you get answer equal to minus 277.7, 277.7, which is kilojoule per mole. So now you have to report this in nearest integer. So answer is 278. You have to report the answer as 278. Okay. Now let's do the next question. 2CO plus O2 gives 2CO2. Fine. We have 2CO plus O2 gives 2CO2. C graphite plus O2 gives CO2. And we have to find out the enthalpy of reaction of this. C graphite plus half O2 gas gives CO gas. So we have to find out delta H naught of this one. So see, C graphite plus O2, right? C graphite plus O2. ठीक है. See how to solve this. We need graphite on left hand side. ठीक है. So if we see B, reaction number B. So graphite is on left hand side, right? Graphite is on left hand side. That's it. Coefficient of graphite over here in the desired reaction, that is 1, and here it is also 1. So it means you have to write down the reaction as it is. That is C graphite plus O2 gas gives CO2 gas. So for this, enthalpy change is equal to minus Y. ठीक है. Then we need CO on the right hand side. So if I need CO on the right hand side, I have to reverse A. I have to reverse A. So I have to reverse A. So if I reverse A, so I get 2CO2 gives 2CO plus O2. Right or wrong? We get 2CO2 gives 2CO plus O2. But now here coefficient of CO is 1. So it means I am going to divide this by 2, 2 and 2. Right? ठीक है. So now if I am going to divide equation A by 2, then enthalpy of this is also divided by 2, and on reversing it is going to be plus x. So enthalpy changes plus x by 2. Clear? Now if I add these two equations, I get this equation, right? I get this equation. So what I have done, B as it is, reverse A, reverse A. You have to do reverse A and then multiply by 1 by 2. So here enthalpy is equal to minus Y, and here initially enthalpy it was minus X. On reversing it becomes plus X and divided by 2. And when you add this, so you get the desired reaction. So enthalpy change for this reaction is going to be minus Y plus X by 2. So which is equal to X minus 2Y by 2. So answer is going to be 3. Answer is going to be 3. Now let's do the next question. Solid fuel used in rocket is a mixture of Fe2O3 and aluminium in the ratio of 1:2. So we have Fe2O3 plus aluminium. So when they react, they form Al2O3 and Fe. So that is in the ratio of 1:2. So on balancing, we get 1:2 only. Fine. The heat evolved kilojoule per gram of the mixture is. So we have to find out the heat evolved per gram. Per gram. So first we have to find out delta H naught reaction. So in the question, formation enthalpies, they are given. The formation enthalpy of aluminium is 0 and iron is 0. Why? Standard state. Standard state. So that is equal to 0. So here we can say delta H naught formation of Al2O3 minus delta H naught formation of Fe2O3. I am applying this summation of enthalpy of formation of product minus summation of enthalpy of formation of reactant. So Al2 enthalpy is minus 1700 and this is minus 840. So minus 1700 plus 840, it becomes 860 minus 860 kilojoule per mole. So this is minus 860 kilojoule. Now we have to find out heat evolved per gram, right? So let's find out the molar mass of mixture. So molar mass of mixture, that is Fe2O3 and Al, which is 1 is to 2. So we can say 2 into 56 plus 3 into 16 plus 2 into 27. So on solving we get 214 gram. So 214 gram releases kitna energy? 860 kilojoule. So 1 gram will release 860 upon 214 kilojoule, which is equal to 4 kilojoule. Okay, 4 kilojoule. So answer is 4. Answer is 4. Now let's do the next question. A2 plus B2, it gives 2AB. Okay. And delta HF is minus 200 kilojoule per mole. Now AB, A2 and B2, they are diatomic molecules. Fine. Bond energy of A2, B2 and AB, they are in the ratio of this. So see, delta H naught reaction, if I want to calculate from bond energy, so that is going to be summation of bond energy of reactant minus summation of bond energy of product. So here we can write bond energy of AA plus bond energy of BB minus 2 into bond energy of AB. ठीक है, तो delta H naught reaction is the formation, right? So that is minus 200 joule. Now they are in the ratio, right? They are in the ratio of 1 into 0.5 into 1. 1 into 0.5 into 1. So we can say like this is 1, this is 0.5 and this is going to be 1. ठीक है? They are in this ratio. So we can say this is going to be 1x plus 0.5x minus 2x. Clear? So it's just we have to solve the question. So when you solve this, so x the value, it comes out to be 400. X का value, it comes out to be 400 on solving. Okay. So if x का value comes out to be 400, so bond energy of AA, it is equal to 400. ठीक है? 400 kilojoule per mole. Yes, that's the answer. ठीक है? Now let's do the next question. 28 liter of CO2 is produced on complete combustion of gaseous mixture of ethene and methane. So we have ethene, which is C2H4 plus CH4. So on complete combustion, we get CO2 plus H2O. So we get 28 liter of CO2 and this is the 16.8 liter gaseous mixture. At 25 degrees Celsius and 1 atm pressure, so this means that is normal temperature pressure. Normal temperature pressure, so we can say volume is directly proportional to number of moles. Okay, so here we have to use the mole concept also. Question says heat evolved during the combustion process. How much heat is evolved during the combustion process? So first we have to calculate the number of moles. Then with respect to number of moles, we can find out the total heat released or total heat evolved. So let's do this. So we have C2H4, that is ethene. O2, it gives CO2 plus water. So let's balance 2, 2, then 3. So if we have x liter of C2H4, so it gives 2x liter of CO2. Understood? 2x liter of CO2 because volume is directly proportional to number of moles. Then we have CH4 plus O2 and it gives CO2 plus H2O. So let's balance it. So we get 2O2. So total volume of mixture is 16.8. So if I'm taking ethane as X liter, so this is going to be 16.8 minus X. So it produced 16.8 minus X liter CO2. Now total CO2 is going to be how much? 28 liter. Fine. So that is 28 liter, which is 2x plus 16.8 minus x. So we can solve for x. X comes out to be 11.2. X comes out to be 11.2. So it means here, okay, from here, so this x is 11.2 liter and this is going to be 16.8 minus 11.2, which is equal to 5.6 liter. Perfect. Now, how to solve this? Now we have to calculate number of moles of C2H4 and number of moles of CH4. How? PV is equal to nRT. So number of moles is PV upon RT. So pressure is 1, volume of C2H4 is 11.2, R is 0.082 and temperature is 298. Why I am taking R ka value as 0.082? Because pressure is 1 atm. So if pressure is in atm, then we have to take R का value as 0.082. ठीक है. Similarly, NCH4 is 1 into 5.6 upon 0.082 into 298. So when you solve this, you get 0.458 mole and here you get 0.229 mole. ठीक है. 0.229 mole. अब now you have to find out the heat evolved. So we have 0.458 mole of C2H4. So heat evolved per ethane is minus 1400 and for methane is minus 900. So minus 1400 plus 0.229 minus 900. So on solving you get answer minus 847.9, sorry not 945 kilojoule. 847.45 kilojoule. Okay, so answer is going to be this one. That's it. Now let's do the next question. The enthalpy change for the conversion of half Cl2 gas to Cl minus aqueous. Okay, fine. We have to find out the enthalpy change for this one, delta H. Now dissociation enthalpy is given, see, 240. So if I want to dissociate, we need Cl. So see, energy required is bond dissociation energy divided by 2, or we can say enthalpy of dissociation divided by 2. Why? Because Cl को if you break, so we get 2 Cl. We have half Cl. We have half Cl. Wait. Yeah. So Cl को if you break to get 2 Cl. If we have half Cl2, so we get only 1 Cl na. So we require half amount of the dissociation energy in order to convert half Cl2 in Cl. Fine. Then what we are going to do? Add electron. So electron gain enthalpy, we have to, electron gain energy released with respect to electron gain enthalpy, and we get Cl minus gas. And then we have to add water, and that is equal to delta H hydration of Cl minus. So we have to apply which law? We have to apply Hess law, right? We have to apply Hess law. So Hess law says whether the reaction occurs in single step or in more than one step, then energy is going to be same. So we can say delta H is equal to delta H dissociation divided by 2 plus delta H Eg plus delta H hydration. So just solve it. Dissociation 240 divided by 2, electron gain minus 350 and hydration minus 380. Okay, so when you solve this, you get answer minus 610 kilojoule per mole. So answer is 610. Okay, 610. Now, let's do the next question. Enthalpies of formation of CCl4, H2O, CO2 and HCl, they are given. So magnitude of enthalpy of reaction given below is. Okay. So delta H naught reaction with respect to formation enthalpy, summation of enthalpy of formation of product minus summation of enthalpy of formation of reactants. So how to solve this? 1 into delta H naught F of CO2 plus 4 into delta H naught F of HCl minus 1 into delta H naught F for CCl4 plus 2 into delta H naught F of H2O. Right, now all the values are given to you. You just need to put all the values, and when you put all the values, you get answer equal to minus 173 kilojoule per mole. Right, so you have to report the answer in nearest integer. So reported answer is 173. Clear? That's it. Just solve it. Okay, next. The standard heat of formation at 298 Kelvin of ethane is given if the heat of combustion of ethane, hydrogen and graphite are this, right? So you have to find out the heat of formation of ethane. So देखो, ethane is C2H6. So how to form ethane? Carbon plus hydrogen gas, and this is graphite. So 2 and this is 3H2O. So how to find out the delta H naught reaction from combustion? Enthalpy, we can say 2 into delta H naught combustion of carbon plus 3 into delta H naught combustion of hydrogen, now minus 1 into delta H naught combustion of C2H6. ठीक है, अब now you have all the values. It just you need to put all the values, right? You need to put all the values together and find out the answer. Okay, can you find out the answer on your own? So please, now you have all the values. Let's put all the values. So when you put all the values, so enthalpy of reaction, it comes out to be minus 192.5. Okay, minus 192.5, and that is going to be in kilojoule per mole. Okay, it's just you have to put all the values. Okay, that's it. Now let's do next question. If enthalpy of atomization of Br2 liquid is x kilojoule per mole, atomization, so it means Br2 liquid is converted to Br to Br gas. So this is equal to the enthalpy of atomization, and that is equal to x kilojoule per mole. And bond enthalpy of Br2 is y kilojoule per mole. So bond enthalpy is equal to bond enthalpy, like we get 2Br. So that is equal to bond enthalpy, which is y kilojoule per mole. Right. Up now, if I want to form Br gas, so liquid is converted to gas na. So here we have to provide enthalpy which is equal to enthalpy of vaporization. Right. Up now, if I apply Hess's law, so delta H naught atomization is equal to bond energy plus delta H naught vaporization. So that is X. Bond energy is Y plus delta H naught vaporization. So we can say X is greater than Y. Right? So answer is 3. Answer is 3. Now let's do next question. That is the last question, right, for the thermochemistry. So let's do it. Enthalpy of sublimation of iodine, enthalpy of sublimation of iodine, yani it is converted to I2 gas, it is equal to 24 calorie per gram, and this is the enthalpy of sublimation. Fine, per gram के लिए at 200 degrees Celsius. Fine. Now if specific heat of I2 solid and I2 vaporization are 0.055, fine, and 0.031 calorie per gram per Kelvin respectively, then enthalpy of sublimation of iodine is. Okay, so I2 gas, that is 200, and we have I2 gas at kitna 250 degrees Celsius. Okay, fine. So how to solve this? We have to find enthalpy of sublimation of iodine at 250 degrees Celsius. ठीक है, तो here we are going to write use a Kirchhoff's equation. How? Delta H naught T2 minus delta H naught T1 is equal to delta Cp T2 minus T1. So delta H naught T2 को I can write 250 and here delta H naught that is 200. Delta Cp, what is Cp? Delta Cp. So I2 vaporization वाला specific heat minus I2 solid वाला, ठीक है, because specific heat is given ना. So simple, so we can write 0.031 minus 0.055. So here we can say 0.031 minus 0.055. Specific heat, molar heat capacity, right, at constant pressure. So that is going to be same. T2 minus T1, it is equal to 50. Delta H naught 200 is minus 24. Basically it's 24. So it's just you have to solve the calculation, right? And when you solve the calculation, so you get delta H naught 250 is equal to 22.8. 22.8 calorie per gram. So answer is going to be third. Okay, so that's it. We have discussed enough number of questions over here. Enough number of questions, and I have tried my best to accommodate all the questions which are related to thermodynamics and thermochemistry. I hope you like the one-shot series of thermodynamics. In this, we have discussed enough number of problems related to thermodynamics and thermochemistry, which will give you enough practice and which will give you the idea about how to solve the questions. Right. So, if you want this kind of videos and if you want to have more revision with respect to the concepts, right, then it is highly advisable to join the PracBee's revision program. So in this revision program, we have divided 10 blocks in 10 weeks, and each week we are covering 2 or 3 topics. So in the class itself, we discuss the concepts related to the chapter ongoing in that week, and in the video, we discuss some previous year questions or some important questions which will give you enough practice for your JEE Mains, or we can say for your upcoming JEE Mains. And if you want to connect with us, then there is a link, right? There is the link in the description box. You can comment and then you can join the program, right? So thank you so much. So see you next week. In the next week, I'm going to cover the equilibrium. In the equilibrium, I'm going to cover chemical equilibrium and ionic equilibrium separately, and then in next video, I'm going to discuss the chemical kinetics. So basically, we have 3 chapters for the upcoming week. So see you next week. Take care.